Welcome to the first part in our Mech Minutes Timing Belts and Pulley series. Over the next few videos, we'll be covering the basics and most frequently asked questions when it comes to choosing, installing, and using timing belts and pulleys and similar power transmission systems. In this episode, we'll be discussing belt selection for power transmission systems, taking a look at timing belts, V-belts, flat belts, and chains for chain and sprocket systems. Before comparing each system for pros and cons, several elements need to be considered in any application when deciding on a type of power transmission. Overall system or package size, environment considerations, and application-specific requirements, including food grade or food safe requirements, and anti-static or conductive systems for electronic applications. Important operating environment considerations include environmental temperature, both extremely high and low temperatures, which can create problems for belts. Large dust particles or debris, increasing belt tension and adding excess wear to the belt. And, depending on the belt material, grease or oil exposure, which can cause the material to break down more quickly than normal operation. Urethane belts are better in these environments. Also, if there's any chance of your belt and pulley operating in the presence of ozone gas, a urethane or rubber belt with an ozone block chemical may be less prone to material degradation from ozone, as standard rubber belts may eventually exhibit similar breakdown characteristics as high-temperature environments. While these are some of the more common operating environment concerns, make sure to evaluate your application for any others. With the application environment taken into consideration, let's look at the different styles of belts and the pros and cons of each. Before diving into belts and pulleys, a common power transmission system is the chain and sprocket, which works well for longer length applications by adding more links, has a low startup cost, can be used in conveyance with lugs, and works well in extreme temperature ranges. There are, however, a few downsides, including metal-on-metal contact, causing more wear and noise, the necessity of lubrication, and more frequent maintenance periods. Using a belt and pulley system can help to minimize these issues, as they typically require no lubrication and longer maintenance periods. Friction systems like flat and V-belts can be cheaper belt options. However, due to their construction, have lower efficiency, generate heat, and have lower power generation than timing or synchronous belts. V-belts do operate with lower noise, which can be an important factor to consider. And flat belts are usually the most cost-effective belt option available. But both types, being friction systems, require the highest belt tension and may cause excess loading on the bearings and overhung load on the pulley shafts. Timing belts maintain system timing better through the use of a toothed profile and toothed pulleys or sprockets, and typically have a higher power density, allowing for smaller belt and pulley packages for a similar load. Because of these improvements, timing belts are also usually a more expensive option, so carefully evaluate all requirements when choosing a belt type. As mentioned before, the operating environment may cause some issues with the belt, especially in temperature extremes. But if you're using it in an approved temperature range, using a belt and pulley system may be your best bet. And for applications which require superior timing and load or power transmission, a timing belt is the way to go. Already have a belt and pulley system, but are concerned about when to replace the belt? Our next episode will go in-depth into typical belt wear signs and can help you diagnose imminent belt failure.